Howdy, AP PreCal. It is Ms. Kosh. In this video, I decided I wanted to teach sum and difference identities a little bit differently, and I thought I'd make a new video. So if you go through my channel, you'll probably find 10 videos on the sum and difference identities, and it's all the same content, but I'm just going to do it a different way this year. So let's get started. But before we do, my nephew said I should advertise our coming up concert on my YouTube channel. So Michael, I did as you asked me to do. My sister, my nephew, and me, we all play in the same orchestra, and we have a concert, not this Saturday, but next. So there you go, Michael. That was your shout out. The information is on here if you actually are local and want to come. Okay, let's do math. Okay, so the first thing I want to point out here is if I look at, I switched my calculator to degrees, and I know AP PreCal keeps us in radians, but if we think sine of 30 degrees is 1/2, sine of 60 degrees is √3/2, well, does that mean that sine of 90 would be, well, since 30 plus 60 is equal to 90, does that mean that sine of 90 is equal to sine of 30 plus sine of 60? Well, no, because 1/2 plus √3/2 is not equal to 1, which is sine of 90. That may have been a little confusing. But basically what I'm saying is that if you try and say, well, basically we have fancy identities that we can use that allow us to find the sine of two angles added or subtracted together. So this is how I remember it. Keep in mind, my AP students don't get a single formula provided for them. My IB students get a formula booklet. But for AP, what I remember for the sine rule is I remember sine, cosine, cosine, sine with the same SIG in. Okay, so why did I spell SIG in? Because the sign, the plus or minus, if it's a plus here between the angles, then it's a plus here between the two different terms. And if it's a minus here, then it's a minus there. For cosine, what I remember is cosine, cosine, sine, sine with the opposite SIG in. So with cosine, if it's a plus here, notice it, if you haven't seen a minus plus before, what that's saying is that the top goes with the top and the bottom goes with the bottom, okay? So cosine of two angles added together ends up being cosine, cosine, sine, sine with those two terms subtracted. Okay, tangent is not required for AP PreCal, but it is cool and worth knowing maybe. Depends on, but it's not AP PreCal, and this is in the 3 courses I teach, only HL kids need to know this one. Okay, so what I have here is we're going to use this to find sine or cosine of something that's not on the unit circle, but can be created from things on the unit circle. So what I might do, I have us doing each of these problems 2 different ways. You wouldn't obviously have to do that in the real world, but I wanted to show you what happens. What I would probably do with something like this is I might say, oh, this is, like I might say, how do I get pi over 12? I would get pi over 12 by saying 3 pi over 12 minus 2 pi over 12. Well, do those reduce to something that's unit circle friendly? 3 pi over 12 would reduce to pi over 4. 2 pi over 12 reduces to pi over 6. And that's this scenario right here. Okay. And so my sine formula is sine of the first thing, cosine of the second, cosine of the first thing, sine of the second. Okay, so the little way, it's not really a rhyme, but the kind of the rhythmic way that I like to say that is sine, cosine, cosine, sine with the same SIG in, and that's for sine. So if this was a minus, this becomes a minus right here. And so now all of this is unit circle. So I know my unit circle really well. I know this is √2/2. I know that cosine of pi over 6 is √3/2. I know that cosine of pi over 4 is √2/2, and I know that sine of pi over 6 is 1/2. Okay, this term, √2 times √3 is √6. √2 times 1 is √2, and they all have a denominator of 4. And so there's the exact value. Okay, so let's see what happens if we did a different method. On this one, this is like saying 10 pi over 12 minus 9 pi over 12. Notice this reduces and this reduces, which is correct. 10 minus 9 is 1, so 10 pi over 12 minus 9 pi over 12 is 1 pi over 12. So sine, again, was sine. Well, you could write it sine, cosine, cosine, sine, kind of helps you with that rhythm, with the same SIG in. There's a minus here. And what was the first term? 5 pi over 6. Cosine was 3 pi over 4. Cosine is the first angle is this, the second angle is that. And now we're back to the unit circle. So when I told you it never goes away, I did not lie. Sine of 5 pi over 6, where's the 5 pi? It's going to be 1/2. cosine of root 3 over 2 is now a negative root 2 over 2, minus cosine of 5 pi over 6 is a negative root 3 over 2. And sine of 3 pi over 4 is root 2 over 2. If you think I went too fast on this, then you need to go back and practice the unit circle, okay? I think you should be that fast, if not faster, by the time you get to this point in the course. Okay, I went straight to this. So this becomes a negative root 2 and now a positive root 6, and it's all over 4. You'll notice those are equivalent. Super. Okay, now I want us to do this one two different ways. Let's come up with our scenarios on our own. So what I might do, I could say 4 pi over 12 plus 1 pi over 12, but that doesn't help me because this is unit circle friendly, but this is not. And I don't really want to use the answers from up here. I mean, I can, but that would just be a painful way to do that problem. So what I might say is that I might say for method 1, I could say 3 pi over 12 plus 2 pi over 12. And so this would be cosine of, this reduces to pi over 4. Oh, I need a parentheses. And this is pi over 6. Okay, so it's cosine, sine, with the opposite SIGN. Okay, because if it's a plus here, it's a minus there. So then cosine of pi over 4 is root 2 over 2. Cosine of pi over 6 is root 3 over 2. Sine of pi over 4 is root 2 over 2. Sine of pi over 6 is 1/2. This actually ends up being the same answer as before, but that's kind of, I didn't mean to do that, but it just happened. So notice it's the same, but whatever. Okay, another way, let's use subtraction for this next one. So I could say, how do I get 5? I could do 8 minus 3. So let's see, 8 pi over 12 minus 3 pi over 12. Do those reduce to something that's unit circle friendly? I think so. This is cosine, 4 goes in there too. So this is 2 pi over 3. This reduces to pi over 4. Okay, so then this is cosine, sine. Sine is how I remember that with the opposite SIGN. And so that's the first angle, the second angle, the first angle, the second angle. This is not the only way to remember this stuff, but I think it's the way I do it, and so that's what I'm showing you. Cosine of 2 pi over 3 is negative 1/2. Cosine of pi over 4 is root 2 over 2. Plus sine of 2 pi over 3, sine is going to be root 3 over 2. Sine of pi over 4 is root 2 over 2. I see a positive root 6 and a negative root 2, which is exactly what we have right here. So there we go. Okay, let's see. Sometimes they like to ask us questions where they give us some context. So they'll give us information about two different angles. So they may tell us sine of an angle and cosine of a different angle, or so, who knows what they'll tell us. But then they tell us where it lives. So notice this is between pi over 2 and pi. So that means our angle is in quadrant 2. Another way to say this is that A is obtuse. It's going to be obtuse in quadrant 2. It would be acute in quadrant 1, and we don't have a name for quadrant 3 and 4. We would have to kind of just tell you where to put it. Okay, so sine is going to be opposite over hypotenuse. So this is going to be a negative 4 right here since it's going in the negative direction. So I can write all this out to have it ready to go. Cosine is negative 4/5. Tangent is negative 3/4. And actually, I don't need tangent for these problems because they no longer require us to do the tangent sum and difference formulas, but here we go. Okay, the next one, I put us in the same quadrant. I don't know why, but I did. And so we're here again. Cosine is adjacent over hypotenuse. And so this is an 8, 15, 17 triangle. So sine is 15 over 17. Cosine we already know to be negative 8 over 17. It matches right there, but now it's all laid out for us. Tangent would be a negative 15 over 8. Okay, and so now they've asked me to do these 3 different scenarios with the sum and difference. And so I can say, so sine, remember, is sine, cosine, sine. I didn't give myself enough space, with the same SIGN. Okay, so let's just, there we go. Sine of A, so this would be equal to, sine of A, I wrote it down here, is 3/5. Cosine of B is over here. That's negative 8/17. Minus cosine of A is right here. That's a negative 4/5. And sine of B is 15 over 17. I'm going to have to find another piece of paper because I'm writing too big. I see a negative 24 and a positive 60 all over 85. I think this is a positive 36 over 85. I hope I know how to do arithmetic. I might not. Okay, the next one, cosine of A plus B. Let me just give myself more space. So cosine is cosine. Oh, I was trying to write the B too soon. Sine, cosine, sine with the opposite SIGN. Okay, I'm a little too zoomed in. My apologies. There we go. Okay, so cosine of A, we wrote it down. It's over here, negative 4/5. Cosine of B, we wrote it down. It's negative 8/17. Sine of A is 3/5. Sine of B is right here, 15 over 17. Could you see all of, yes, you saw everything I could see. Okay, so I see a 32. I see a, what is that, negative 45 over 85. Negative 13. I see negative 13 over 85. Cool. Okay, then the next one, now I should have enough room for this one. This one I see, so sine, cosine, sine, with the same, since it's sine, it's with the same SIGN. Sine of A, we wrote it down, this is 3/5. Cosine of root 3, cosine of pi over 3, we should know. Cosine of pi over 3 is 1/2. Did you see how I made my little triangle in my head? That's what my pencil was doing. Cosine of A is negative 4/5. Sine of pi over 3 is root 3 over 2. I see a 3 minus 4 root 3 all over 10. I'm perfectly happy with that answer, but if it wasn't in the multiple choice, you'd have 3 over 10 minus 2 root 3 over 5. I don't care. Those are the equivalent. I'm fine either way. Okay, so far so good. We have 3 more problems. And here we go. Okay, so on this one it says condense this, and I see sine, cosine, which is very similar to what I'm used to. I'm used to cosine, sine. So let's switch this. The cosine is still negative, and the sine is positive. But we're not used to seeing a negative out here, so let's factor it out. That makes this a negative. Okay, and so now you may notice this matches the scenario here of cosine, sine with a minus sign, which means that it's going to correspond with the plus sign here. So this, we still have this negative out front, but then this becomes cosine of, I don't know that I really needed that parentheses, but there it is, cosine of the first term and then the opposite. So here's the first and the second. And instead of a minus, we now have a plus because cosine is the opposite. 3x plus 1x is 4x. And so our final answer is negative cosine of 4x. And you can write it without any parentheses at all. Super. I think this is fun. I love trig identities. Okay, the next one. So they're trying us to prove this equals this. It means pick a side, stay on it, and turn it into the other. There's more stuff happening on this side, so let's try that. So cosine is cosine, sine with the opposite SIGN, so it's a minus. So this is that first part, and then I'm going to add to it the second part. Do you have to have these parentheses? No, but does it help you see where things connect to? Yes. So cosine, sine with the opposite SIGN. So this was a minus, now it's plus. Okay, so I have 4 terms. I see that these 2 terms are the same, so there's 2 of them. I see that this and this are the same, but one's positive, one's negative. So I'm just left with, this is 2 cosine x cosine y, which is equal to 2 cosine x cosine y, which is what I wanted. That, I would argue, is pretty easy proof. Okay, last one. Now, sometimes people remember all these identities where you've taken your angle and you've rotated it a quarter of the way around the circle and that kind of stuff, and they know that these things are true. I always forget those, and so I prefer to use the sum and difference. So I might say, okay, so sine, it's sine, cosine, sine, with the sine is the same, with the same SIGN. So it's sine, cosine, sine with the same SIGN. And so this sine of pi over 2 is equal to 1. No. Yes. Oh my goodness. Okay, time to go home. Cosine of x minus cosine of pi over 2 is equal to 0. That one's equal to 0. And so 0 times that, that's gone. So I just have cosine of x is equal to cosine of x. And life is good. All right, like, subscribe, comment, let me know how I can help you, and the only way to learn math is to practice, so go practice. Good luck.